Hello and welcome to my fourth tutorial on code in 3D on the Nintendo DS. In this video I'll go over a complete game. Well, I say complete, I've not added in like a game 1 screen as it's an Invaders game. The usual thing with the Invaders games is it just gets more and more difficult as you go on. I don't think there's any real sort of ending to it, it just kind of continues. Anyway, let's carry on. Right, so the topics I'll go into is, as this is a 3D game, I sort of had to decide how I wanted to view this. Most of the things you'll need to do when you make a 3D game is decide which sort of camera you want to use. You have like a few sort of options. There's obviously the first-person camera, the third-person camera, which we'll be using here, where your camera is kind of pointing at the object of your game, usually like a sort of player, and following them around. Or you could just have like a camera in 3D space pointing at a scene from a certain angle. So I'll go over the third-person camera and how I've set it up in the demo game. And then I'll also talk about some of the simple animation techniques I've used in the game. And then we'll jump into the game code itself and I'll sort of highlight a few bits of it that I think are of note. I won't be touching on display lists or anything like that. This is purely about the third-person camera and the game code. I'm assuming that you've watched the other videos, as the topics covered are kind of in order. So as a quick reminder, the rotations, obviously the X rotation is a roll, Y rotation is a yaw, which kind of rotates around the center, and the Z axis is a pitch. And then the other thing to be aware is, as we're sort of working with OpenGL style here, the minus Z axis is depth. So minus Z goes into the scene, plus Z comes out of your screen, plus X goes across to the right, minus X goes across to the left, plus Y goes up, and minus Y goes down. Obviously all of that is relative to your camera's orientation. So our third-person camera, this is our camera here. This is the origin or the position of the camera here, and then we have a few key things we need to give the camera to get it working as we wish. So we have an above distance from the target. This is kind of like how high up you want the camera to float above your sort of target. And then we also need to know how far behind the camera should be trailing. And then we need the target's position. But rather than looking directly at the target, I find it best to kind of look to a point in front of the target. But these things kind of vary depending on what you're trying to present in your game. There's no sort of a real golden rule for what things you need. You could easily do away with the look in front. But it's in certain games, if you sort of try and envision how the third-person camera works. If you were to sort of look around, you would want to kind of look past your avatar or player into the scene, which is kind of what we need for our Invaders game here in 3D. I found that I couldn't directly kind of look at the player's ship. I kind of needed to look past it into the distance, so we can kind of see our player's ship and see that the game is in 3D, But at the same time, our main focus is on the invaders and them coming closer to us, as we need to get an idea of where our targets are, because we're targeting them to shoot at them. And then in other sort of 3D games, we would want to know the yaw value of the target, as you can kind of think that the camera is kind of, you kind of position the camera first on the target and then you kind of move it back relative to the above and behind. You could obviously put in more complicated bits and pieces here, like you could have like a pitch value in with the camera as well, so that the camera sort of like pivots around. So you could have the camera sort of do that. So in 3D that would be pivoting on the x-axis. You could obviously in our game here we update the camera's position every sort of time the player moves, but you could put like a delay in that, so that when the target moves, the camera slowly then responds and follows the target, so that you would kind of get like a sort of delay, which would result in you seeing kind of another side of the target to some degree. There's lots you can kind of do. Loads of things depend on what you're kind of what your the game you are deciding to make, whether it was like a third person shooter or like a third person platformer or what have you. What you need to what's relevant to see is obviously game dependent. Right, I don't think there's anything more I need to do in Inkscape here, so I'll save this and close this, and then we'll take a look at the models I used here. So if I bring the Blender scene across here, so these are some of the key objects we've got here. So the bases are made of cubes. I'll talk more about that in a minute. That will make more sense. In fact, what I'll do is I'll show the game now, so we can so you'll get a better understanding of these models here. So we start off, we've got like a bitmap screen in the background here, like a space sort of scene, and then a simple title screen here. And then you can see here the bases we've got are cubes. And then one of the things I decided to do here is, if you envision how the 2D game Invaders works, your bases kind of gradually get destroyed by bullets hitting them. So I kind of wanted to do something similar here. So the bases are made of a number of cubes here, and then I decided to change the colours of the cubes when they're hit. So each cube part of a base has a life value, so they gradually sort of erode over time. And then you can see here our camera is positioned at the start slightly behind our player ship, and then looking down into the scene here where you can see our invaders set up. I decided to use simple textures for them in the end. One of the limitations you'll find on the DS is the low resolution that it has. When it comes to 3D, obviously these things are quite far away from the camera. So the further things are, the more it will sort of struggle to be able to sort of view any detail on it. So you have to kind of play around with the resolutions of the textures you use on your models, as I have with this game here. So in the end, I kind of settled with the distance you see here for them, and I decided to create some sort of variations of the textures which I used here. I'll jump into that in a moment. So we have some different states to the game, which I'll get into in a moment. So as you can see, we can we've got some parameters to zoom in and out there, and then there's another one there where you can kind of almost totally change the style there. So I left the ability to play around with all of the different settings of the camera there. Oh, I think I've broke it there. Anyway, let's get into the models here. So you might have noticed the way that they were sort of walking. So what I did there was kind of a simple technique where if you zoom into our Invader model here, in fact I'll hide some of the others as we don't need to see all of those. Right, we'll focus on this one here. So what you'll see there, that's the center there. Whenever you create these 3D models, you always need to make sure when you export them that they're at location 0. There's no rotation on them, and their scale is 1 on every axis here. So what this dot there represents is the center of rotation for him or her or whatever it is. So once you've created your model, so what I've done here is these are like 3 separate parts here. So if I separate them, so I'll separate that by selection there, and then you'll see that these have kind of come apart here. Now they've split apart here, so you can move that a minute. Oh, that's not what I meant to do. hoping to do here is to select all of the parts that make up that foot. So you see that the shape itself is kind of like a sort of pyramid here. The head is a bit more in depth. One of the things to bear in mind is if you're going to have a load of different like enemies, you want to keep it fairly simple. Again, lots of it will be trial and error to some degree, as once you export this, you obviously don't want it to be too over the top with detail, just in case the DS can't render it all. I can't tell whether it's selected all of it or just that face. Let's try that again. Okay, it's worked that time. So when I designed the invaders, all of these were all separate parts. You'll see that once you, if you join them together, like I did there, to export them, you kind of need to join them together to sort of create like a one large object when working with like simple animation techniques. You'll see here that the orientation is messed up for this now. So one of the things to do with this one would be to first set the origin to like the center of the mass, and then I would put the X coordinate back to 0, and you'll see that the that sort of shape there is the 3D cursor, and then I would snap the origin to the 3D cursor. There you go. And now the no, that's screwed up again there. That's irritating. Let's see whether the other one is it's only took the front face again. Anyway, when you sort of build this shape or build a model, what I actually did was the legs are separate, and then I kind of first exported this whole thing here as one frame. As I went over in the other video there, you're just exporting it as an OBJ file. So you'd make sure that your faces are triangulated. You want to keep the vertex order as well, and then you would save that one frame, and then what you would do is you would then move the leg up, select everything again, then you'd export it, put the leg back to where it was, then move the next one up, and then do the same again. Don't worry about the fact that the back of it's not sort of showing here. This is just an issue I'm having here because I joined everything together. When you sort of join everything together, it then sort of treats it as one mesh, and then to sort of break everything apart again, you need to go into edit mode, and then you kind of need to link everything. I think it's that one there. That's the main one. I think loose parts. That's what I wasn't doing just now. Okay, yeah, that's got it there anyway. And now when you construct it, you will obviously construct it from simple sort of shapes there. You'll see here I've deleted the bottom of the model here, and also the bottom of the feet. I won't bother sort of giving you the OBJ file for this, as it's not really relevant to the Invaders thing here. The idea is you kind of should be looking to sort of create your own characters, replace the Invaders with them. So one simple technique, like I was saying, is when you build these, like in the case of the Invader here, you'd keep the everything sort of separate, and then you'd move things to how you want them to move. One of the other things I did in the actual game itself is one other way to sort of do simple animation is you can obviously rotate these things and scale them, and then also move them away from the actual position they're at when you do that. As in, this is the sort of origin here, and then you could have like it's sort of scaling like that. With the ship, you'll see that it had like the like fire sort of coming out the back of it. That fire model is this star here, except it had a different texture, and I rotated it by 90 degrees like I've just done there. And then you could scale in that, and also moving it away from its start position is how I sort of created that effect of the flame. It was literally just moving away from the player ship and scaling as well. Some of the bullets in the game are literally just like a pyramid, which is rotated and scaled. So if I rotate that, and then if we look at it from above, and then we scale that, that's kind of how I was creating the bullets, but with actual game code rather than from the modeler here. When it comes to more complex animation, I'll go over how we can sort of handle that in the next video. So that's pretty much all I want to show for the modeling side of things here. These are all these are the main sort of models. Obviously the player ship is slightly different. It's kind of like a pyramid like this, except it's rotated and has the sort of like the back filled in, but the bottom removed. In fact, let's see if we can find that one now. I think this is the one here. Yeah, here we go. Unfortunately, you can't see the one of the things I did when I created this was I put like a Decepticon texture on it here, but due to the low resolution that the DS has, you can't actually see that in the scene, unfortunately, which is a pity. So this is the kind of like model I used here. Again, fairly simple. You see, I didn't remove the bottom of it there. And you'll also see that I didn't bother properly texture mapping the bottom either, as we won't be seeing it in the game. It will always be seen like this. And then here we have some of the textures I used here. So we've got a few different low resolution textures for various flames and bullets. One of the things I didn't show you was the player explode. I created like a dome model. I think it was in another video of a dome, but yeah, I just reused that one. So see what else I want to go over here. So I will provide these invader textures here, just so you can see how I kind of did it. So you'll see we have various parts of the model textures laid out here. We have the invader sort of face, and then up the top here there's a part set aside for the foot part of the invaders. In this instance, in this game, all I did was I created like a paletted version here. And then made sure I kept these colours all the same. That way I could literally just change the colours when uploading the texture as a 256 colour texture without having to make exact copies of the image over and over again. I could literally just have the one green image and then just make sure I save the palettes from the others. So I will include some assets for you to use, the Invaders one for a start, so that if you wanted you could have a muck around just using LibreSprite and just redecorate, redesign the faces and the feet of the Invader models, if you didn't want to add your own, that is. And then I'm not sure if that's the ship here. I obviously changed the texture for the ship. I think this is the one I used here, so I will include that as well, so you can have a play around with changing the colours of the ship. I think that's pretty much it here. Oh yeah, one of the things I also wanted to show as well was one of the problems you'll have with the 3D games when you sort of design them is trying to figure out how big everything should be in relation to each other. That is that's a common sort of issue I have with different games. For example, it took a bit of time playing around trying to figure out how large the invaders should be compared to everything else. As certain sizes worked better than others, you obviously want to have enough action in the scene and you also want to be able to clearly sort of see the details on the invaders. The problem you sort of have is the further away you zoom out of the scene on the DS, the more quicker it becomes unrecognisable because of the low resolution, which is something that happens on all low resolution consoles. You kind of need to keep things fairly close to be able to see them. So one of the things I sometimes do, and what I had to do here, was I decided to kind of mimic like a 2D sort of style here. So I decided to work with the normal sort of tile map you would have for the DS to come up with where the bases should be positioned here. So what I did was I created a 32 by 24 pixel image here, so each pixel represents a tile in the game. And then I used this so that I could sort of plan out where the bases should be and how big the bases should be. I also used this to kind of decide where the player should start as well, just by looking here and saying, okay, the player will start here. And then if you look, when you plot pixels in LibreSprite here, you get the sort of pixel location here. And then using that location, I would then record it in Level Manager here. So you see we have the 4 bases, and then we have their starting positions here. So you'll see that x coordinate 0, 1, 2, 3, and then the y start is 5. Now the thing is, when you're working with 3D and you're sort of drawing these things, the y position isn't sort of starting here. You're starting here and then going forward. Obviously, in this case, it's on the z-axis. So one thing to note is that this is on the negative z-axis here. So this is -1, -2, -3, -4, and that's actually -5 into the 3D world. Tile-wise, anyway. So you kind of, when you're sort of doing these things, you kind of need to sort of do it sort of like back to front. Your starting position on 3D will always be bottom left, and then going forward into the world. The more you sort of dive in and play around with 3D, the more comfortable you'll sort of feel with it all. I just thought I'd share that. And then this was like another mock-up I was doing to kind of come up with what I actually wanted to sort of see. This isn't obviously what we're seeing in the game as it is now. This was just like an early sort of prototype, like how many invaders do I actually want in the scene, or can I physically have and see clearly. And then another thing you'll sort of need to do as well as part of the planning is to sort of come up with where the details of the game as it's playing needs to be positioned, like the score, the title, and then if you've got any icons. So what this relates to here, if I bring up the large font set here. So one thing to note is I have an 8x8 font and an 8x16 font here. So the 8x16 font also contains some like icons for the game. Obviously the images themselves are 16x16, but as they are part of the font set here, you have to draw them as if they are 2 8x16 images, like the fonts, like graphics themselves. So you'll see here, this shape here is the world where it will be positioned in tiles on the sort of the heads-up display background layer. And then this is the Invaders text here, and this is the player's score. So I use this to decide where to position those to make them sort of look right. I didn't in the end put anything on the bottom of the screen, as I kind of thought it could obscure or hide the sort of player and their exhaust flames. So I didn't do that in the end. So this is another thing you kind of need to do with games as well, is once you've got the game working correctly, you then need to kind of plan out where your text or the information you're going to put across to the player is. So I decided to use these ones here as like life icons on the bottom screen, and I didn't bother animating them, but I could have done if I added in like a timer to do that. So maybe that's something that you might want to do yourself in your version of this. And then another thing I need to point out here as well is as these are 16 color tile sets, the colors for these are put at the very beginning, and then the background image, I think it uses like 240 colors. It was put starting at color 16. I'm not going to go into that, as there is no sort of real point here. This is the font set for the game. I'll include this for you so you can use that as you see fit. Right, let's jump into some of the code now. So most of the stuff here isn't really anything new. Like most of these projects I put across here, lots of it you'll have to jump in to the code to sort of dissect what's going on. Hopefully most of these things are made clear. I think most of the objects in the game I've parameterized like this here. For example, you'll see that the base blocks which make up the bases themselves. So the bases themselves, if we if I bring up the image again, not this one. So if I bring this up again here, each base is basically like a 4 across by 3 down grid, and then each of those tiles or those cubes are size 8 for the X, Y and Z. And then if we look at the level manager thing here, what you'll notice, so this is the template to sort of construct this base here, but as you'll notice it's actually upside down here. And that is because as we want to draw it, we'll be drawing this part first, as we'll be starting at the bottom here and then going into the scene on the Z axis. So in this image, this is the Y axis, but obviously in the game it will be the negative Z axis. So we'll come to that part first, which is what we'll sort of, whenever there's a 1, we will then add one of these cubes as the base. So it's kind of like upside down as we are drawing it. Going forward, we'll obviously draw this first, then this, and then this here. So each of those cubes are 8 in size. So if I split this across here, this is probably one of the most interesting ones here. There's a lot you could kind of do by mucking around with destroyable, or rather destructible parts here. So how this kind of works is we have a base part which represents one of those cubes. Each of those cubes has a collision rectangle associated with it, and they have like a health value. In this case, I decided to only give them 3. Again, you can put whatever you want in yours. Correct that. And then like I said, I put out where I wanted the player to be in relation to each of those sort of pixels being size 8 in the world. So you can kind of think of the each of those like squares as being one block, which is 8 in size. Again, loads of these sort of like sizes of stuff is entirely up to you to sort of come up with. For me, I found 8 worked fine. Again, loads of it depends on the amount of detail you want to kind of put in. So we have a base part, which is one of those cubes, and then we have a base structure which is made of those base parts, and then we have an array here of those parts, and then you can see here I've set aside here what the numbers of them are. So there's 8. No, sorry, there are there's actually 12 of these, but rather than include the blank ones, I didn't bother. So if you decide to change the shape of these, which you could do, you could make it into like a plus shape. In fact, we'll do that now actually. So now we've got a plus shape. In fact, I don't need to change the number here as it's exactly the same. So if we save that and then rebuild it. And then if you go into it, there you go. You can now see that that's now a plus shape. But you can pretty much change it to whatever you want. So you could have it as the a normal sort of. We could do this. Yeah, that's still. So that now takes. Yep, that's still 8 there. Yeah, you see it's upside down now. I should have done it the other way around. As you can see, it is it's flexible. So if you decided to use all of these, you'll need to increase the number there. And then we have like a global sort of rectangle perimeter there, which covers all of those, this whole sort of shape, if you like. So rather than individually check each of these base parts every update of the game, we kind of give them their own sort of bounding area, and we only check with the bounding area above it to limit the amount of collision checks we have to do, and then we would only sort of check each of them if the boundary has been intersected. And then we also record how many of the base parts are alive. So that's pretty much the stuff I wanted to cover here for this. This just add base bit here. This just kind of sets up each of these bases here by scanning our array here. Nothing too complicated there, as you can see. Initially I was going to do some other sort of fiddling around, possibly like as you go to like higher levels, maybe there aren't as many bases, but I decided not to do that in the end. And then you could also use the level ID as well to maybe change the sort of graphics for things as the levels progressed, but I didn't do that in this case here. And then the collisions are straightforward. Just takes in like an actor's like collision rectangle. We need to know what actor type, and the reason for that is when the invaders march down the screen, if the invaders collide with one of the bases, they should totally wreck them. There shouldn't be any sort of health value considered. It should just obliterate them. Otherwise they would kind of obscure the invaders. And then the update function here, although it says update, it's actually sort of drawing them. I should probably have called it draw or render, really. So all this does here is draws a floor and then draws the bases. The textured quad, which I've function there, which I've covered in various other videos, that is actually quite useful for the floor there. Although I kind of find that the floor should probably be a different texture, as it kind of looks kind of dark on the DS light. Probably should be like a different texture so that the bullets stand out more, but I'll leave what's there as it is. So the level manager is something more interesting that I just wanted to go over here. You could use this for various other stuff where you want like destructible backgrounds. You kind of use it, I suppose, as like a platformer or something like that. So I'll now sort of cover some of the sort of camera stuff here, which is one of the key things that this is about here. So you see we've got like two functions here. We have like two sort of initialization functions here. This one here just takes the starting position for the camera and the yaw angle of the camera. So this is like a first person one here, and then this is our sorry, this is a first person, this is our third person here. As you can see, we have the sort of target position, if you like, and then we have our above value, behind and in front, and then a yaw value, which in the case of the Invaders game we're not actually using. Most of this stuff we are not actually using in here. The only things we'll be using are the a set ABI function, so that is like a set above, behind and in front. And then the follow target function, which just takes the target's position and the target's yaw angle. The idea is you would kind of set these up once, and then you would just use the follow camera function, and then the camera would literally just, using the above, behind and in front, would update itself. So if I scroll down to it here, we kind of take the we get the angles of the target's yaw, and then we position ourselves behind it on the X and Y. So two of these relate to the actual camera's position, which are like SX and SZ. And then we have DX and DZ, which hold the in front of the camera position. And then we basically use the camera update function here with the GLU lookat to set the model view matrix. So I'm not sure whether I went into any more detail in these model matrices here. So basically, you have like the key ones we're interested in is you have the perspective matrix, which is just kind of like a 4x4 table which holds how the perspective transform should be done. That is like how to transform the 3D scene into a 2D scene to actually draw it to the screen. And then we have the model view matrix, which handles how things are translated to the sort of like the world scene. Again, working with these different matrices, the more you sort of do it, the more you feel sort of comfortable how things are going. It's easy to sort of have a play around with stuff if you don't kind of know what's going on here. Most of the time in OpenGL, you just you set the perspective one up one time only. I think this is done in Scene 3D here. You see that here you go. When we initialize the scene here, where is it? Let's get down to it. So although this function's in here, I've not done anything with it in this game here. So the projection matrix basically tells the DS how to transform the 3D scene when it's finished into a 2D like bitmap for it to actually draw, which is what the GLU perspective function actually does. So usually you kind of would just sort of call this once, and then everything else in your game is usually the model view matrix, which is how models are positioned relative to the coordinates you kind of put in the model view here. Maybe that made sense to you, I don't know. Again, as you sort of play around with OpenGL possibly, or this here, it will kind of all sort of come together hopefully. So all this does, like I said when I was talking earlier, you kind of get the target, and then you kind of move away from it with the camera's position itself. You position it behind, and then above, so you'll see here the core camera parts are split out here before we call camera update. We set out the position of the camera and then what we are actually looking at. So you see we have like the in front distance times the target's angle, and then we have the position behind times the target's angle with the sine angle and the cosine angle there. So you should sort of set these, you would set these up before you sort of call the camera follow. And then you'll see this one here is kind of hard coded in as we sort of take the target's Y position and then we just kind of -1 from that. So you could add another sort of parameter, and instead of -1 you can change this to whatever you kind of like. But again, that would kind of totally change how you kind of see things. Like I was saying, there's a kind of no one size fits all when it comes to the different sort of cameras. It's kind of like I kind of find this sort of works fine for sort of third person. The only thing you kind of need to do is play around with the above, behind and in front to kind of get it to match how you want it to behave. As you saw in the example earlier, I didn't set in any constraints and I was able to kind of break the view by mucking around where we kind of went too far with one of these parameters and then kind of wrapped the camera around on the opposite sort of side angle wise, which is possible. So one of the other things you should kind of do in your own games as well is play around with the angles and the distances to sort of stop that from happening. Obviously this video here is for you to sort of see that you what sort of effects you can have by sort of playing around with that. So that's kind of all for the camera 3D thing there. Let's see, what else should we talk about? The meshes possibly. So all of these were obviously created with the OBJ tool, which was in the previous video to this one. So I'm not going to go into any of that here. What you'll see is that I created, like I said, there's 3 frames for the invaders. There's a, if I jump into the invaders code here, so this is obviously frame 0 here. That is the one where both of the feet are on the ground, and then frame 2 is where one foot is up in the air, and then on the other frame it's the opposite foot that's up in the air. And then by alternating the frames, we can create a similar sort of animation to how you would in a normal sort of 2D game where you flip the images. That's one thing you can do to get some simple 3D animation. One of the other things I did as well was, if I come down here, in fact I might need to show the header file for this. Oh yeah, just like the normal sort of Invader games as well, there's like a few states I think that the invaders go through depending on how many of them are actually left in the scene. So I thought it would be interesting to display the names of them here in a state array. And then we also have the move speeds here, which ramp up. Again, you can play around with all of these. See just how hectic you can make things get. And then there's the number of them are kind of limited as well. Again, play around tweaking all these things, see how you go. I think it's all kind of laid out fairly cleanly. So I'll get back to the other animation I was doing with the invaders here. So when I was drawing them, I was also changing one of the angles as well, which I found worked well. Yeah, here we go. So along with some of the animation frames, I was also rotating on the y-axis and the z-axis, and that kind of felt like it was emphasizing the movement. So if we jump back in here so you can quickly see what I'm talking about. You see, not only did their feet go up, but they also kind of rotate slightly, so it gives more of a feel that they're kind of moving. So that's another sort of a simple thing you can do as well, is to add in like rotations for the models. So I'm sure I sort of covered the 3D model structure in the last video, so I won't go into any of that here, but this just gives you an easy sort of structure to work with, dare I say it, an object orientated kind of way. So you can kind of like abstract away from the individual sort of parts and then just concentrate on what the invader should be and how they should be moving around. So we also have a structure to hold some simple things about the invaders here. So one of the other things I decided to do with the game as well is that as you sort of progress, the invaders have kind of like an increase in life count, so they become harder and harder to kill. And then I also increased the bullet rate as well. All of the collisions in it work with just rectangles rather than more complicated collision shapes. Maybe I kind of should introduce some of those in the next video, possibly like I don't know, maybe like a collision sphere or a collision cube possibly, which are useful collision objects in 3D scenes. Anyway, all of the stuff here is fairly straightforward. We have a collision function for checking if something has collided with a bullet, and then we have a separate function to notify us if something has collided with an invader. In fact, that reminds me, I think I haven't put in a collision between an invader and an actual player. Not sure what difference that would make later on in the game. Anyway, we have like a value here for the game kind of, or rather you lose a life if the invader reaches the bottom of the screen. I haven't really done too much with this either. The core sort of stuff with the game was really the invaders shooting and the player shooting and showing the third person camera, so not everything is totally stitched up to make it watertight as a game. There are a few things you could do yourself. So anyway, some of the other things in here. We kind of have to flip the Z-axis all the time as well. So you'll see here the player is literally just almost in 2D as well, where we have only an X and Y coordinate here. And then when we convert this into sort of drawing it in the 3D world, rather than create like a load of an array of the 3D meshes or 3D models, sorry, we have just one which we update over and over again for each of the invaders. We kind of set up the mesh to be an invader here using its size, which we only need to do once. Obviously its size is where are we? Its size is here. Again, these were kind of trial and error to kind of get it to kind of look kind of decent. If you have it too small, you obviously can't see any sort of detail on the face. Whereas if the bigger you have them, the less of them you can kind of have. I kind of didn't want the level to be sort of too wide. Although there is obviously no reason why it shouldn't be or couldn't be. So the one model was used over and over again here. And you'll see here to set the mesh ID, we get the frame. We have like a global sort of frame for all of them. But then each invader, when it's created, has its own texture ID, which is based on the amount of them that we have. At the start, it's kind of like randomized. And you'll see here when we come to actually when we come to actually draw in our invaders. Oh yeah, so the reason why the bullets are drawn first is so that they appear behind the invaders. One thing to note with how you sort of draw things as well is you kind of need to draw things in reverse, if you like, so that certain things appear in front of others, just like in 2D. So we iterate over the invader array here with this pointer here into the array, and then if the lives are greater than 0, we set the mesh texture to whatever the invader's texture is. We can use the invader's X coordinate. The mesh Y position is the sort of kind of like the height, if you like. Kind of make sure that they are kind of like above the scene. The tile size variable here, this is like a global I defined in utils here. So one sort of tile is kind of like 2 base blocks in size. So we kind of, this is half of it though. When I sort of put a H at the end, that's kind of to signify that it's half of that value. The reason why I define these at the start here is so we don't need to compute these values over and over again continuously. And then you'll notice that the Z position is Y, reversed, as like I said before, the negative z-axis is what goes into the scene, which is what we sort of look down through the camera. So by keeping this positive, it allows us to kind of just work with the whole game as if it was like a 2D game, which just makes things easier. And then just then draw the model there. Nothing magical there, like. And then the bullets are fairly sort of straightforward. Again, we use the same sort of principle here. I think there is like I think there's a bullet object I created. Where are we? Yeah, here we go. Look. So again, to animate all the bullets, we first rotate them on the x-axis 90 degrees, so they're kind of bent over, if you like. And then when we rotate the y-axis on all of them, it gives another sort of interesting feel, like the sort of bullet is kind of spinning as it's moving forward. That sort of stuff is all in the bullet Invader update here. There we go, if the bullet's alive. So we have our array here of bullets. If it's alive, then we rotate it by like a fixed value. So this is one of the few things I haven't sort of parameterized here, which I should have done. And then once we move it, we sort of set up its rectangle, its collision rectangle. So I think the actual bases, let's double check there. Oh no, that's just the actual collision rectangles are what's used to actually position them. That's the yeah, rather than having like an X and Y position, then we're just actually moving the actual collision rectangles themselves. So one of the other things I sort of had to do here was I think there's a function to get the center of a rectangle. No, I didn't add that in actually. So by having the bullets as like a rectangle from the get-go, it made it easier to just collide with here. And then I had it so that if a bullet hits a base, then you just kill the bullet. And then we keep track of the invader bullet count, as there is a limit to how many they can fire at once, which I believe is parameterized. Yeah, there you go, 4. Again, play around with that number if you want to see how it goes, if you like sort of add in like 50 bullets or something, but I'm sure the game would be insanely difficult if you did that. And then when they sort of spawn, oh yeah, there is a thing here we use to set them. So the collision rectangle is kind of centered on an invader. I suppose this is something to cover here as well, actually. This function here, get shooter. So the way this kind of works is we get a random number between 0 and the maximum amount of invaders, and then we kind of pick an invader at random. We then see if it's alive, and then if it is, we record its position, and then we return that position. See, this returns a vector 2 here. And then we then use this spawn position to center the rectangle of the bullet on. And then we give it a random speed between 1 and 3. I don't think I parameterize these numbers either. However, if you've watched this video, then you'll know that it's not parameterized, so there is that. If you didn't watch the video, then you wouldn't know what I'm saying here, so you won't know what these do, so watch the video. Don't skip ahead. And then my usual sort of debugging is I bung in these error trap functions here. It should never reach here. It should always get here. This probably doesn't actually need to be here, actually. If all the bullets are in use, it should not fire anything. However, in the testing I've done, I've not noticed this actually occurring, so there always seems to be a free bullet. I'll comment that out anyway, as if you add in more bullets, maybe that could cause an issue, possibly. That's all for the Invader. If there's anything else you'll want to know about that, then check out the code. It's pretty well documented. And then in the player code, almost called it a class. I kind of like to think of them as classes, but obviously these are modules and header files in C speak. So in the player we have our move speed. These are just values that are sort of picked. There's no reason why they need to be sort of hard coded as such, but I find it easier to change things. And then you'll see here these camera height and camera behind here, as all of the camera code is baked into the player code. When we draw the player, we have our camera above, behind and in front code, and then we pass in the player's position and 0, as we are not rotating the yaw at all. I've not actually played around to see what would actually happen if we did actually. I'm not going to do it now. I'm tempted, but I'm not going to do it now. Again, with the player here, we treat the player as if it's a 2D character. And then just like with the invaders, we negate the Z position. And then you'll see we have some different states for the player. So I'll quickly show those, what they're there for. So we have like normal, dying, and dead. So if I get him, there you go. The dying involves the dome with the fire texture. I didn't include it for the enemies, like, so if you look at them now, you'll see the these bullets that they fire are the diamonds. I need to reset that. Otherwise I'll be sending you this with wonky bases otherwise. Yeah, so these states here basically switch out what's actually being drawn when the player draw function is called. If the player's dying, then we change the mesh. Well, in fact, we draw another mesh on top of the player, which is the dome. So we select the fire dome mesh, and then set the fire 4 texture. And then the bullets have their own sort of draw thing here. Again, they work similar to the Invader bullets. They're pretty much the same. Probably should have had like a bullet manager, but that would kind of complicate things a bit more. The these are kind of hard coded at the start here. This probably should be, I'll do that now. So it's, in fact, no, those are actually do not want to save any of that. So if we get back up here, so what these actually are, there are some limits are set for the behind and the minimum height, but I didn't set any maximum stop values. For the in front, above and behind. So there should be like some defaults here possibly. We'll put these in so that it makes it easier for you to have a muck around with it. There we go, and then we will set these here as well. There we go, that makes it a lot nicer here. So the PL reset or the player reset is called at the start of a game, or if you kind of die and then you restart the level. So we basically reset the camera. I should probably have another function for resetting the camera actually. So I think the select button isn't used, so we could probably have that there. As I never sort of crashed the camera with my tests I was doing, it kind of makes sense to put these in here. Then we can just if you come like a cropper in the game where you've put the camera to such a weird sort of state, it'd be good to sort of call that from the game. So I think most of this stuff is fairly straightforward. Oh yeah, there is a value, how far above you can kind of go. But I believe I didn't do it for behind. So one thing to note is there is a possibility that the behind can actually travel in front of the actual player's ship, which probably is what sort of caused the issue earlier. I'll leave this as it is for now. I don't think there's anything else in here I need to sort of cover. It's fairly sort of straightforward. Just have a check through there. And then the game code. I will quickly go over some of this and highlight some bits and pieces here. So when it comes to the sort of like game logic, one of the things I like to keep is the sort of game states, and then we have some like game messages states, and then we have substate values. You may think, why have we got all of these? Well, sometimes when we first change to one of these game states, there might be something we need to initialize just the one time that occurs, and then that's where these substates come in handy. And these values here, I'll explain. The explode animation for the dome is actually handled externally here in the game code rather than in the player code, which is why these are in here. I was kind of tweaking to get the speed to a reasonable value. So there's some various things here. One thing I will add in is in the gameplay code. So each of these states are clearly separated here. So what we'll have there you go. We'll add in the reset code there. as my neighbours are doing the hoovering now, I think I'll conclude this video, as I don't know if you can hear it or not. So check out the code. I'll leave you some assets to play around with. Right, that's it for this video. In the next video, I will go over a more complicated way of animating 3D models using the rotation, offset, and scale parameters. So we'll kind of create like a virtual sort of skeleton structure to hold models, which is better and gives you sort of more control. Any questions, leave them in the comments below, and I will catch you in the next video. Hopefully you've found this useful.